Hello and welcome to video 2 of 2 parts for section 6.5. In 6.1 we started with using law of sines and it gave us the values for a triangle. Using law of sines we have to be careful, and we have to be careful when we're talking about if we're given two sides in one angle. The reason being is that the numbers could work out using law of sines to give you values, but the values themselves may not actually create a triangle if you were to try to draw the picture. So we have the following. If given two sides and one angle, we have to be careful because we could end up with two triangles one triangle or no triangles. So we could get mathematically values that work for using the law of sines, but if we tried to draw a triangle given our values, they wouldn't actually work to make a triangle. So let's look at our first case. So because of this, we need to always check the answers we get. Does it make logical sense? So the first triangle we're going to look at, we have the following. So let's call this ABC. Side A is 7 square root of 2. Side B is 7. And angle A is 45 degrees. So we want to find out what's the length of C, what's the angle of C, what's the angle of B. So given this information that I was provided with, the first thing I can do, the only thing I can really do using law of sines is what? Figure out angle B. So I have the sine of B over the length of B, 7, is the sine of A, 45, over the length of side A, 7 square root of 2. So to get sine of B, I have to multiply both sides by 7. So I get 7 times sine of 45 over 7 square root of 2, which means that the sine of B is equal to a half. So because this is a nice value, we can use our unit circle, or if you're using your calculator, you do your sine inverse function. It gives us what? It tells us B is equal to 30 degrees. Okay. So if I plug that in here, that B is equal to 30, I also have to consider what? If you remember back in 6.4, one of the questions said find the angles between 0 and 180 degrees that satisfy sine is equal to some value, right? Why did we use 180? Well, because a triangle has 180 degrees. So sine of B is equal to half not only at 30 degrees, but also what? Also at 150 degrees. And we have to look at both cases. Does this make sense? So if B is 30 degrees, that means what? A is 45, B is 30, that's 75 degrees. So that means what? That angle C would be 105 degrees. But what if B is 150 degrees? Well, there we have an issue though, because if A is 45 and B is 150, if we add those two together, that's 195, which is already more than 180, so that can't be a possibility. So in this case, we're not going to consider that B is equal to 150 degrees. Numerically, it works, but logically it won't, because a triangle, we couldn't have an angle of B of 150 degrees. So now we have the three angles, we have the two sides, so we just need this last side, which is C. So that means what? It means that sine of C, sine of 105 over the length of C. And again, just as in the first video, I'm going to use the information I was given. I was given both pieces of A. So this is equal to sine of 45 over 7 square root of 2. And again, using algebra, I move stuff around. I end up with C is approximately 7 square root of 2 times sine of 105 all over sine of 45. So if I punch this on my calculator, I get that C is approximately 13.5. So now that I have that, I have to ask myself, does this make sense? Well, we know given a triangle, the two shortest sides have to sum to a value greater than the longest side. Otherwise, let's say I have a triangle that looks like this. One side is 6, one is 8, and it says maybe the bottom one is 21. Well, would this even be possible? And the answer is no, right? Because if the bottom is 21, if I just laid this side down here, the 6, maybe I get this far. And if I just drop the 8 straight down, it might get me to here, but together they're what? They're 14. So if I lined them straight up, I'm still 7 units short to actually build a triangle. Well, I know that 7 plus 7 square root of 2, if I add them up, it ends up bigger than 13.5. So in this situation, all the values, all the final values I have would work out and could feasibly be a triangle. All right, so now let's look at another case. Let's say I want to solve triangle ABC given the following. Angle A is 43.1 degrees. Side A is 186.2, and side B is 248.6. So I'm not even going to draw the triangle yet. I have what I need, right? Angle A, side B. So knowing or using the law of sines, what do I get? I get that sine of B over the length of side B, 248.6, is equal to sine of A, so sine of 43.1, all over the length of A, 186.2. So if I multiply both sides by 248.6, I get sine of B is 248.6 times sine of 43.1 all over 186.2. If I calculate these numbers on the calculator, I get sine of B is 0.91225. So that means that B, if I use my sine inverse function, is approximately 65.8 degrees. But again, as we saw in this last problem, as we saw in the first video, or no, I'm sorry, in 6.4, we have to subtract this value from 180 because there is two possible values. So it's 65.8 or 180 minus 65.8, which is 114.2. So now do either of these work? Well, 65 plus 43, that's about 108. So that's okay. I still have an angle left over for C. And 114 plus 43, that's what? It's about 157. So that one is still okay because that's under 180 degrees. So in this case, I actually end up with two possible triangles. So now let's draw the picture so that we can calculate all of these possibilities. So we have what? We have the triangle. And so to kind of keep things straight here, I'm going to use red. I'll call this one B1, and 114.2, we'll call that B2. So if here's angle A, here's angle C, for B1 at 65.8, that would be maybe somewhere down here. So angle A was given to us 43.1. If this is B1 at this point, the length of B is still the same. That was given to us, 248.6. And then the angle of B1 is 65.8. But then B2 is 114.2. So it's an angle bigger than 90 degrees, right? So it would be something maybe down here. And so you can see if this thing was attached up here at point C and this line just swung back and forth like a pendulum on a clock, it could basically hit at 2 points. It could hit over here at B1, it could hit over here at B2. And the numbers would still work out using law of sines to give us those values. And so B2 we say is 114.2. So now, again, I'll stay color coded here so we can keep track. Let's first solve for B1. So if we say B1 is about 65.8 degrees, well then that gives us what? So we'll call this angle then the red C1. So C1 would be about 71.1 degrees. Now using law of sines, again the information I was given, so side A, so this one would be here. Side A is opposite A, so this is either 186.2 here or 186.2 there. That was given to me at the start of the problem. So continuing on, we're looking at the triangle formed by the red. B is 65.8, C is 71.1. So that means that length C1, which would be the whole longer length down here, is what? We get sine of C, so sine of 71.1 over the length of C is equal to the sine of A, because that was given to me, so 43.1 all over 186.2. Again, do the algebra, move stuff around, crunch it on a calculator. You should get C, or we'll call it C1 at this point, is approximately 257.8. So does that make sense? If this whole long line here, the red, was 257.8, well, the two smaller sides are 248 and 186, which if we add them together is clearly bigger than 257. So for case 1, that works out all right. So that's one possible triangle given the information we got at the start of the problem. How about B2? So we said B2 is about 114.2. So C2 would be 180 minus 43.1 minus 114.2, which would be about 22.7 degrees. So again, set this up the same. So sine of 22.7 over the length, now we'll call it C2, which would be that shorter piece there, is equal to sine of 43.1, again we're going to use A, all over 186.2. Again, you do the algebra, so you multiply both sides by C2, multiply both sides by 186.2, divide by sine of 43.1, gives us that the length of C2 is about 105.2 units. So then the question is, does that make sense? Do the two shorter sides added up Are they bigger than the other one? And obviously they are. 105 plus 186 is about 291, which is bigger than 248. So you can see here, given the information at the start, we can get two possible triangles. And that's why we got to be careful when we're doing these calculations, considering all these possibilities. Now, I'll say this. Given these problems, what were we doing? A lot of calculator work, right? So what are the chances that a problem like this shows up on your in-class exams? Or what's the chance a problem like this shows up on your final exam? You guessed it, 0. It's not going to be on there because you don't get to use calculators. So this problem you could not even do on an exam. But you have to be careful because you will be doing law of sign problems. So just be careful that the answers you get, you consider the different possibilities. All right, let's look at one more example for this section. So for this one, we're given the following. We want to solve triangle ABC. For angle A is equal to 42 degrees. Side A is equal to 70. Side B is equal to 122. So again, I'm not even going to draw the triangle. I don't know what this thing looks like yet, but I know I have angle A, side A, and side B. So I can do what? Law of sines, say sine B over the length, 122, is sine of 42 over its length, 70. If I multiply across here, I get sine of B is equal to 122 times sine of 42 all over 70, which tells me that sine of B is approximately, again using a calculator, 1.17. Uh-oh, we got a problem. Why? Well, we know that sine can never be more than 1. This goes back to the earlier sections where we were dealing with the inverse functions, sine inverse, cosine inverse. So it can't be more than 1, and if you try this, if you put 1.17 on your calculator, hit inverse sine, is going to come back with a big error message, which means we can't find an angle for B that makes this true. So that tells us what? It tells us that there is no solution. So essentially, we could not draw a triangle that had these three pieces of information as being true. If we get to a point where we get our error message, it just means there's no solution for that triangle. All right, so that was video 2 for section 6.5. I'll see you guys in 6.6, the law of cosines.